In this question, the question stem doesn't give us a lot of information. We know that n and m are positive. We should also note that these two variables may or may not be integers. What we want to know is whether it's true that m is less than 9 and n is greater than 9. Let's turn to the data statements, evaluating them separately first. Statement 1 bears a resemblance to what we are attempting to determine. We see that m times n equals 81. If the two numbers were equal, then each would be 9, obviously, but they're not equal. That means that one will have to be less than 9 and one greater. Since m is less than n, then m must be less than 9 and n must be greater. That's sufficient. We could work this algebraically as well. By starting with mn equals 81, we could then convert it, divide it both sides by n, to obtain that m equals 81 over n. Secondly, given the equation in the data statement and plugging that in, we get that 81 over n is less than n. Multiplying both sides by n gives us n squared is greater than 81, or taking the square root, n is greater than 9. A similar process confirms that m is less than 9. We can reason this out through logic or through algebra. Statement 1 is sufficient. Statement 2 gives us what we ended up obtaining from statement 1 after algebraic manipulation, so it is also independently sufficient. We could take the square root of the left, middle, and right side of this equation, since all the numbers are positive, and that also gives us exactly what we're looking for. So statement 2 is sufficient, and the correct answer is D.